right off the bat. You win a free Zoom call with your favorite mentor. For PFAs. Yeah, you know, for anything really. I'm tired, man. You proved RJ was the spy. Should have known to never trust RJ. That's, you know, that's our bad for doing that. Why could we ever think that we could do that? Sorry, trying to get set up. He's at 1.3, so 1 1/3. Yep, nailed it. I think that confirms it too. I think that's all we needed to hear. The final nail in the coffin. Oh God. How many spies can there be? How many of you are plants from College Board? All right. All right, let's try this stuff out. Reminder again to Park Hill High School kids. I sent it out in the email, but meeting today at 1 o'clock with the AP coordinator from Park Hill High School on Zoom. I sent you the link. As at 1. I'm just told you're expected to be there. I don't really know, but it should be relatively short, like 15, 20 minutes. Probably just a review to make sure everyone's on the same page of stuff. Otherwise, on your own, you should be logging in and practicing with the AP demo. All right. You should check to make sure that you have your confirmation for the test. So whether that was emailed to you or you should be able to see it somewhere on when you log into My AP. Either one of those, you should see a confirmation of some kind, as well as a confirmation that RJ is a spy. And then besides that, you should just be working on practicing and studying. Right? Again, definitely, besides just doing stuff we do, should absolutely be utilizing the Advanced Placement Calculus BC playlist on YouTube that they put out. This morning they put out the video that was like, what was it called? I already forgot. Let's look. Oh, right now, live now, AP Music Theory. Right? Hayden, don't you always lie and say that you're in some sort of music class? Maybe you should be watching AP Music Theory right now. Did you even consider it? Yeah, today's video, AP Calculus BC exam tips with guest speaker. I don't know who that guy is. Right. Tomorrow, AP exam timed AP exam practice number 2, the day after exam practice number 3, and on Friday, final lesson with final exam tips. Okay, so definitely be utilizing those resources. Check that stuff out. You're offended. Why are you offended? Typical. Everyone always getting offended these days, you know? You can't even just insult people like you used to be able to. I would never skip this class. That's right. Well, later, whenever Miss Leah tries to get you in a Zoom call, say you need to watch your AP music theory video. Okay, the function g has derivatives of all orders with selected derivatives of g at x equals 0, given in the table above. The function f is defined by 1 plus the integral from 0 to x of g. All right, so this table is about g and g's derivatives. Okay, however, f is defined by this function. And part A says write the third degree Taylor polynomial for f. Right? Centered around x equals 0, third degree Taylor polynomial. So just make sure that you don't create a third degree Taylor polynomial for g. Right? We have to do it for f. So let's just first write in general. So P3, which represents third degree Taylor polynomial. Why is that the largest? Okay, equals, so I'm just going to write out the symbols, right? So f of 0, because it's centered around 0, plus f prime of 0 times x, plus f double prime of 0 divided by 2 times x squared, plus f triple prime of 0 divided by 6 times x cubed. Now, these three terms come from this formula. Right, so this first term is actually divided by 1 factorial and then x to the first. It's centered around x minus 0, which is why I just have x squared, and x cubed. I'm not going to write out x minus 0. Right, and then this next term divided by 2 factorial, which is 2, x squared, and the second derivative. And this last term, third derivative of f, divided by 3 factorial. 3 times 2 is 6. X cubed. Okay, but if you just kind of have that internalized, you can save yourself some time in writing that out. Okay, well, we need to figure out what these values of f are. Right, so first of all, so let's just kind of create. So f of x is, I'm just going to copy this down, 1 plus 0 to x of g dt. Okay, so f of 0 would just be 1 plus the integral from 0 to 0. All right, but what do we know about integrals whenever the bounds are the same? We're doing an integral from 0 to 0. That means this whole second term is just 0. So 1 plus 0 is 1. The derivative of f, so derivative of 1 is 0. The derivative of an integral, so derivative of an integral, we have to do second fundamental theorem of calculus. So that would be g, right, whatever this is, g, plug in the upper bound, times the derivative of the upper bound. Derivative of x is 1, so times 1, minus g, plug in the lower bound, times the derivative of the lower bound. Derivative of the lower bound is 0, so times 0. So basically, all of this crap, I don't need to write that. But I just wanted to show you that we get this by using the second fundamental theorem of calculus, right? And that's whenever you take the derivative of an integral. Right? The derivative of a definite integral, so you just take whatever's on the inside, plug in the upper bound, times the derivative of the upper bound, minus whatever's in the integral, plug in the lower bound, times the derivative of the lower bound. So all this simplifies to just g of x. Okay, so that means f prime of 0 is just the same thing as g of 0, not g prime. F prime is the same as g. And g of 0 is -2 from that table. Okay, -2. Next, I need f double prime. So f double prime should be the same thing as g prime. So f double prime of 0 is the same thing as g prime of 0. G prime of 0 is 8. It's from the table. And the third derivative of f would then be the same thing as the second derivative of g. So I'll take the second derivative of g and plug in 0. And using my table, -48. Okay, so all of these values are the things that I want because that's these things right here. So I'm going to go back to my Taylor polynomial, right, that I have the kind of general formula of, but now I'm just going to plug in my actual values. So P3, f of 0 is 1. Next coefficient's -2, so minus 2x. Next coefficient is 8, but that'll be 8 divided by 2, so plus 4x squared. Next coefficient is -48, so minus 48 over 6, so minus 8 x cubed. So there's my third degree Taylor polynomial that approximates f. Right? They even try to trick you on this because you'll note they give you the third derivative of g. And so I think what would happen a lot is people see, oh, third degree Taylor polynomial. I have the third derivative of g. I think people would mistakenly make a Taylor polynomial for g. Okay, but again, like we mentioned, this says for f. So g is used to make f, but I think a lot of people, or maybe not a lot of people, but I think that a common mistake that they're trying to get you to make here is that you make the Taylor polynomial, oh, g of 0 plus g prime of 0x plus g double prime of 2 x squared plus g triple prime 0 divided by 6 of x cubed. All right, but this is the Taylor polynomial for g. This is the Taylor polynomial for f. Right, and we have to use g to make f. But I think that's probably why they put this third derivative of g in here, is to try to trip people up and say, oh, I need to make a Taylor polynomial for g, and then they use all this stuff, but we're trying to make it for f. Okay, so we just have to pay close attention. All right, so it's a pretty nifty little Taylor polynomial. Part B, consider the geometric series from 0 to infinity of a n x n, okay, whose first terms are defined by the Taylor polynomial found in part A. All right. So I have a series that starts off with the answer that I got for A. All right, so let me just copy that down and remind myself what I had. 1 minus 2x plus 4x squared minus 8x cubed. Find the sum of this series when x equals 1/4, or show that the series diverges. Right, and this straight up tells me, hey, geometric series. All right. So an x to the nth equals, again, it's telling me, hey, whatever the series is, I just have general terms, right? An x to the nth. This is what's used to make this answer that we got for part A. All right, and it would continue on. Okay, so what I want to do is something that we did earlier on, where I want to create a formula that will make this series. Right now, all I have is a general an, but I want to know what is the actual explicit form. What's the actual formula that will be used to make this series? Because I can sort of see that I have a definite pattern here. Okay. So I can see that my x to the n, that's fine how it is, because my first term, if I plug in 0, x to the 0 is just 1. My second term, x to the first power, yeah, x to the first power. Next I plug in 2, x to the second power, x to the second power, x cubed. Okay, great. So that part's fine. I just now need to figure out what is an. Right? Well, remember, this series starts by plugging in 0. So when I look at 1, 2, 4, 8, I'm either thinking multiplying by 2 or powers of 2. Right? So 2 to the n. Right? Would that work? 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. Okay, great. But now there's also this negative. Right? Sometimes this term alternates. So let me see if I put a negative in here, will that fix it? Move this n over a little bit. Okay, let me double check this. If n is 0, negative 2 to the 0 is 1. Great. If n is 1, negative 2 to the first is negative 2. Great. If n is 2, negative 2 squared would just be positive 4. Great, that's what I have here. And if n is 3, negative 2 cubed, negative 8. Okay, that does work. Now, do you need to write all that out? No, but you probably do want to do at least a quick check in your head of, does this actually make the positives and negatives that I want? Okay, so my series is actually instead of just writing an, I can write negative 2 to the n times x to the n. Right? That's what creates this series. All right, but now this is actually asking about when x equals 1/4. So let me go in and plug in 1/4. to infinity, negative 2 to the n, 1/4 to the n. Exponent rules tell us if these are both to the n, then we can combine those together, all to the power of n, right? Negative 2 times 1/4 would be negative 2 over 4. And I can simplify that. Negative 2 over 4 is negative 1/2 to the n. And now that I've simplified it like this, I can now definitely see that this is in the form of a geometric series. Right? I know that it told me that before in the setup of the problem, but I couldn't really see it. But now that it's like this, I see, oh yeah, this is the format of a geometric series. Right? And so my r in this case is negative 1/2. And so how do we test geometric series? We take the absolute value of r. Is that less than 1? Yes. Absolute value of negative 1/2 is just positive 1/2. Positive 1/2 is less than 1. Since it's less than 1, then I know that this series converges. Okay, but the problem says not only just determine if it converges or diverges, it says actually find the sum. Okay, well, the sum, this is the formula for the sum of an infinite geometric series, if we can prove it converges. Now, we've already proved it converges, so now we can just use this formula to find the sum. A1, the first term in this case, well, we already know the first term is just 1, so that helps us out a lot. 1 over 1 minus, now what's r? Negative 1/2, so 1 plus 1/2. One over 3/2, 2/3. This is mostly just manipulating some things, and then it tells me, hey, plug in x equals 1/4. Manipulate some stuff some more, and say, oh, okay, now this looks like a geometric series, so it must converge, and here's how I find the sum. Right. As a brief reminder for the AP test, you guys need to know, remember, because not all of that last chapter or that last unit, but you need to know geometric series, P series, and harmonic. Harmonic is just a type of P series. Alternating series, and the ratio test. Okay, this is, I mean, this obviously isn't all you need to know, but this is the stuff from that last what's it called? Last unit. At least in terms of tests. Now you also, from the last unit, need to know Taylor and Maclaurin. But in terms of which tests do you need to, or which tests do you need to potentially know for the AP test, it's these four right here. Geometric series, P series harmonic, alternating series, ratio test. No telescoping, correct. So yeah, what were the other ones? It's no telescoping series, no comparison test, no integral test, no nth term test. Yeah. Also remember, there's no unit 9 whatsoever. So that's polar, parametric, vectors. Yeah. So don't need to worry about that stuff. That helps a little bit. Right, basically just all parametric. Unit 9, polar is just a type of parametric. Vectors, pretty similar. Okay, so that was part B. All right, part C. Let h be the function defined by h of x equals the integral from 0 to x of f. All right, so this is definitely important. Use the Taylor polynomial found in part A to find an approximation for h of 1/4. Oh, interesting. Okay, so all right. So h of 1/4 would be equal to the integral from 0 to 1/4 of f Now, what is the function f? Well, the function f is this, but it's saying use the Taylor polynomial. So remember, what does the Taylor polynomial represent? It represents an approximation of f. F is approximately this polynomial that we found. Okay, so it's saying, actually, this next problem says don't use actual f, use the approximation for f. Okay, so this is approximately the integral from 0 to 1/4 of f, which we approximated as 1 minus 2x plus 4x squared minus 8x cubed. Okay. These two things that I've underlined in the turquoise or whatever here, this is the polynomial that approximates f. So I'm not using actual f. This is the actual formula for f. Okay, but I can't take an integral of this. I don't have an equation. I don't have enough values that can help me figure it out. So that's why we're using the Taylor polynomial approximation. All right, now integral of a polynomial is easy, right? Integral of a polynomial is just power rule, power rule, power rule, power rule. So antiderivative of 1, x. Antiderivative of minus 2x, minus x squared. Antiderivative of 4x squared was a little uglier. 4/3 x cubed. Or sorry, not, yeah. Antiderivative of minus 8x squared, that would be minus 2x to the 4th. And that's from 0 to 1/4. Right? If you don't trust yourself, do a quick test of derivative. Derivative of x is 1. Derivative of negative x squared would be negative 2x. Derivative of 4/3 x cubed, 3's would cancel, 4x squared. Great. 4 times negative 2, negative 8, x, 4 minus 1, 3. Okay, great. All right, so now we just have to evaluate. So plug in 1/4 first. 1/4 minus 1/4 squared plus 4/3 1/4 cubed minus 2 1/4 to the fourth. Right, that's all plugging in the upper bound, and then subtract, plugging in the lower bound, 0. So now I could actually go in and plug in 0, but look, this would just be 0, this would just be 0, 4/3 times 0, 0, negative 2 times 0, 0, so this is just minus 0. And again, this is the AP test. Don't simplify. Leave this crap as it is. Don't bother about worrying about fractions and all that stuff. Once you get to a spot where you could just type it into a normal 4-function calculator, stop there. I mean, I guess you don't, do you have to write out the minus 0 on the end? No. But are you going to get counted off for it? No. It's like immensely painful. I know. You've been taught your entire lives, your entire mathematical careers, simplify as much as possible. But throw that out the window. Okay, so that's approximately what h of 1/4 is. Right? Make sure between these two steps we have approximately as our symbol, because f is approximated by this Taylor polynomial. All right. And part D. Determine if the series from 1 to infinity of -1 to the nth over the third root, cubed root of n, converges or diverges. Explain your reasoning. Okay. Okay, interesting. So, looking at this, part D has absolutely nothing to do with this setup information. Nothing. It doesn't say I need to use F. It doesn't say I need to use G. It doesn't say use the Taylor polynomial. It doesn't say use something from part A, B, or C. This is completely, part D is just a standalone part here. Oops. So it has nothing to do with this information at all. This is just straight up, here's a series, tell me if it converges or diverges, and tell me how you know. Okay, so for part C, I needed to use part A. For part B, I had to use part A. For part A, obviously it's just part A. But part D is just completely, not only do I not need to use a previous part, I also don't need to use any of this setup information at all. Part D is just like a random question. Here, do this. Okay. So will that be like the AP test? I don't know. But it's an important lesson in making sure you know for each piece, what is this telling me to use? Do I need to use information they told me? Do I need to use a previous answer that I found in an earlier part? Or do I need to use nothing? Do I just need to do whatever it tells me to do? In this case, we're just going to do it. All right, so I'm looking at this series, right? And I'm trying to determine what type of series is this so I can figure out what type of test to use. Now, we only have limited options, right? Well, actually, I'm not going to write those out again. They're back here. We have geometric series, P-series or harmonic series, alternating series, or use the ratio test. No, Siri, I do not want to talk to you. Perfect. So I have these 4 to choose from. If on the AP test you have to do some sort of series and tell if it converges or diverges, you have 4 options. Geometric, P-series, alternating series, or use the ratio test. Now, for my problem here on part D, I should automatically know it should be one of these 2. Why is that? Because of this. Right? So, this already alerts me that this is probably going to be alternating, right? Which means going back and forth between negative and positive, because if n is an even or odd number, that will determine if the negative stays or cancels. Okay, so this will be an alternating series. Also, because there's the n in the exponent, remember that's one of the things we like to use for ratio test. For ratio tests, if there's factorials or if there's some sort of n in an exponent, or both especially, I'm thinking maybe ratio test. But since this doesn't have more than that, I'm thinking alternating series. Yeah, this denominator doesn't have n in the exponent. It has n, but it's not n inside of the exponent. So I'm going to try alternating series. All right, alternating series test. All right, so we have to do 3 things in order for the alternating series test to work. The first thing is this. So here's what I consider my an. Right, 1 over cubed root of n. I'm going to write that as 1 over n to the 1/3. Remember, we want to typically rewrite roots as exponents. It usually helps us, especially if we're doing derivatives or antiderivatives. So whenever we do the alternating series test, we leave out the alternating part, right? The -1 to the whatever power. Okay, so first thing I want to check is what is the limit as it goes to infinity? Well, look, as my denominator goes to infinity, yeah, it's going to the 1/3 power, but it's still just getting infinitely large. 1 divided by infinitely large, that's 0. That's the first check. Is the limit of the an, the sequence part, equal to 0? That's the first thing. Okay. Second thing, if we look at, oops, okay. Okay, so that's the first question, but yes, it is. Okay, the second thing we want to know, is an positive? Right? Is it always larger than 0? Yeah, look at this. There's no way that this is ever going to be a negative number. We start by plugging in 1 and then are just going up to infinity. We're always plugging in positive numbers to this expression. So even though this will get very small, it'll still always be greater than 0. All right, so yes, that sequence is positive. And then the third thing we want, is it decreasing? Well, remember, to determine if something's decreasing, we look at the derivative. Okay, is the derivative always going to be negative? Let's see. So let's take the derivative of 1 over n to the 1/3, and actually I'm going to write that as n to the negative 1/3 so that I can use power rule more easily. So that would be negative 1/3 n, negative 1/3 minus 1, negative 4/3. N is always going to be a positive number. So to the negative 4/3, that'll be a small number, but it's still always positive. So always positive times a negative will always be negative. So yes, this sequence always is decreasing. Okay, so we've run through our 3 checks. So again, summary, those 3 checks are take the sequence, so that's just leaving out the -1 part. Limit as n goes to infinity, is it 0? Great. Is the sequence itself always positive? Great. Is the sequence always decreasing? Always decreasing? Great. Okay, so once we've said those 3 things are true, that's our test right there. So by the alternating series test, the series from 0 to infinity, or is it 1 to infinity? I already forgot. 1 to infinity. Of -1 to the n, cube root of n, converges. Explain your reasoning. Yeah, we did that. We said by the alternating series test, and here's our work that shows that we went through all the steps to prove that. And I think that's, yep, that's it for that one. All right, so I'll do my reminder at the end now. Same thing from the beginning. Park Hill High School AP testers, Zoom meeting today at 1 p.m. All right, please make sure that people know about that if you need to be on that call. I sent you the link. I emailed it to you. I put it on Schoology. It should be short, 15-20 minutes, about just whatever information they want to tell you. Be looking at that YouTube playlist from AP, Calculus BC. There's timed practice. They posted one yesterday. They posted a video about exam tips today. Absolutely go look at exam tips. If the people who make the exam put out exam tips, go look at those. Tomorrow they'll have another timed practice. The day after they'll have another timed practice. Friday they'll have some more exam tips. And be practicing FRQs. Go through previous videos on that playlist that talk about FRQ practice. Look at whatever videos on there you need. That's excellent resource because they are the ones that make the exam. So obviously they would have the best review knowledge. Practice other FRQs. Start organizing your notes. Make sure you have things in places where you know they are, or start thinking about what screens you want to have open during the exam. Whether that's the formula sheet, where do you want to have it, what fits, what works well. Go into that demo, see how your setup works. Right? You absolutely need to go through and check out the demo to see what the system will look like. Practice taking pictures of your work. Practice uploading your picture. Practice emailing the picture to yourself so that you can get it on your computer or whatever your process is. I don't know. Get in the rhythm. That way you're not freaking out on test day about something not going smoothly. Right? And then just, of course, practice, practice, practice. Study formulas. The less time you have to spend looking up formulas, the more time that is you can actually solve the problem. And then practice FRQs over and over again. As many FRQs as you can get your hands on. Practice them. And then do them again. All right, any questions for me? cb.org/apdemo. That's where the demo is. In your email yesterday or on the My AP site, you should see a confirmation of you being confirmed for taking the test. Make sure you have that. Otherwise, something's horribly wrong. Okay. Let me know if you have any questions. Park Hill High School kids, show up in that Zoom conference at 1 p.m. And otherwise, I will see you guys back here tomorrow, and I'll have some more practice stuff ready. Okay. All right. Have a great rest of your day.